YB Environmental students. Today we're looking at one more last choice your turn example on Google Sheets, which would be mostly for the folks doing plant identification and quadrats. Alright, so if you're not doing plant ID, you probably should have picked one of the other your choice options because this is helpful for those folks but not for you. Great. So let's say you were doing percent coverage and you did 5 different plot locations, all right, and at each plot location you found different species. So that's a lot of data, which is why we have a lot of different data here in our raw data section, and it's kind of overwhelming. So the way I've organized this is that each of these mini tables is one plot. So table 1 says percent coverage of species in a 10 by 10 meter plot. Notice that's very specific. And that plot is at 0 meters from the stream. And there were 5 randomly sampled quadrats. Each quadrat was 1 by 1 meters. Right? As detailed as we can be in a table title, the better. Right? And here we see the species. I don't know the species that you potentially found, so I'm calling them A through E. That would only be what you would use temporarily. What you should actually have here is the Latin or scientific name, and that would be much more specific, right? So this is percent coverage. If you did actual counts, you would include that, and you're welcome to also look at the macroinvertebrate example, which is also based on actual counts. But whenever we do percent coverage, each of these columns, which is a quadrat trial, a column, should add up to be 100. You could always check by doing equal sign sum, which is a adding function. Select the whole thing, and then check that it equaled 100, and it does. So this whole column equals 100, all right? And you could check that for any of these if you don't really believe me, all right? So what we're really curious is how many species A, all right, what was the percent coverage average for species A in this plot when we were super close to the stream? All right, in this case, I am pretending that we actually did a specific transect distance from the stream, which is ideal, but you might not have that, and you might have a qualitative close to the stream and not have an actual value for how close. All right, and so this here is some processing done nearby, and that's only because if I didn't do some of the data processing nearby, it would be really hard. But we are going to kind of move these so they're organized all into one big process data table that's nice and organized. So let's double check that we did averaging correctly. So I clicked on this cell, which is the average for species A, for all 5 quadrats at the plot 0 meters from stream. And the way this reads, right, it says here in the function, I've averaged cell B7, which is right here, through cell F7, which is right here, and that's correct, all right? And so here, I've averaged this one through this one. So this time, instead of going down, we're averaging across, which makes sense the way I've set up these tables, and that's totally fine. Right, and that's how this reads. So the way I try to save you a little bit of time for this your turn challenge is I've done the averaging and the standard deviations for you. All right, your turn is to do them for some of them. All right, so you need to do it for the 75 meter plot and the 100 meter plot. And I'm going to try to walk you through it in case you've gotten stuck. So let's do it here. So here is the 75 meter plot. And here's that species A, and we want to do the average. So I can type directly into here, or I can go up top here, equal sign for a function. I want to do the average. Click, that was right. I select that I want to average all of the A by dragging across, ending my parentheses, and going there. Oh, look, it did the calculation for me. Average, drag, and parentheses, enter. Now notice that this is following a big pattern, all right? It's always B through F, and it's kind of just changing which row it's on. This one is row 15, and this one's row 16. So it's always B through F, so it's the same pattern. So I can use my ninja trick of dragging that blue box with this plus symbol down and saying, hey, keep that calculation the same. And I could double check, did it really do the right averages? And yeah, it did. If I was nervous, I can retype averages by hand, but that's pretty boring and not very fun. I then want to do standard deviations. Now notice the amount of spread before you do your standard deviation calculation to kind of know ahead of time, should it be big or small. Standard deviation, I start typing it, and it knows what I want, standard deviation. I click it, it gives me my parentheses. I want to do standard deviation for these trials, for species A. I end my parentheses. Now notice it gives me a large amount of decimal places. I don't like that because I want to keep my precision the same. Really, I shouldn't have any decimal places, but we're going to let it go to 1. But we don't want it to go to more than 1 decimal place because that's changing our significant digits. So I'm going to get rid of the decimal places by clicking this function up here, this symbol that says decrease decimal places. Oops, I went too far, so I can increase once. Alright, I'm going to do the same thing, standard deviation. Boom. Do it for this row, and parentheses go. Same thing, it's being a butthead. Decrease the different decimal places. Notice that it awesomely rounds for me. I don't want to retype that every single time, and it's going to follow the same pattern for me if I just drag the equation down. And look, when I dragged the equation down, it even remembered for me that I wanted only 1 decimal place. Now lastly, we want to do it for the 100 meters away from the stream. Same thing, average. I want to average this one. Drag that down. Standard deviation. Equal sign, standard deviation. I want to do it for this section. I don't want all of those different digits. I only want a small number of significant digits. Drag that down. And there I go. So now I have like a whole crazy amount of data. But I want to organize my data into one nice process data table for averages. See, table 6 says average for 5 trials, percent coverage, 10 by 10 meter plots, all of them, distances 100 meters through 0 meters. And now I can see that each of the different plots is listed here as the IV. Alright, and I've pre-filled in this guy right now. The way I did that, I'm going to delete it really fast and show you how I did it because it's going to be deleted on yours. I am going to select from table 4. I highlighted the averages that I want to copy and paste. I go edit, copy. Now if I paste just automatically, it's actually going to do some weird averaging and it's not going to work. So instead, I'm going to highlight, I go edit, paste special, only paste the values. So that makes it so it only gives me these values instead of saying accidentally move the functions that I typed into here and it would accidentally do some averaging. I want to move this guy over as well. Edit, copy, edit, paste special, only the values, please. I'm going to do the same thing for the standard deviations. Copy, paste special, values only. Oh my gosh, I didn't remember that I only wanted a couple digits. Goodness gracious, stupid standard deviation. Alright, and the reason why I want to move these into one giant area is because I want to be able to compare the averages and the standard deviations all at once. And if they're all in one big table, I can say, which trials and which plots had the highest standard deviation? I can see that really quickly because they're all in one place. I can also see approximately, is there a change in the percentages as I move away from the stream? And now I can see that. But if they're all in all these different tables, I can't see that so well. It also allows me right now to start making my processed data graph. Alright, when I do a graph, I only really am going to be graphing averages, not standard deviations, although I do want this organized standard deviation table. Alright, let's start doing our graph. So, I'm going to highlight all this information. Alright, so I highlighted all the way from plot distances, through the species names, which you'd have actual real names, through all of the data, so the whole thing, but not the table title. I'm going to go Insert, Chart. Now remember, I'm smarter then Google Sheets is going to be super weird about this and make some mistakes. I will have to fix it a lot, which is okay, but annoying. Alright, so first of all, we don't want to have a figure title here. We will have a figure title actually typed out either below, figure 1, blah, 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 or actually on Google Docs, we'll type it out. I'm going to click back to data. Now I want to double check that they didn't switch rows and columns, which means the X and the Y are switched. And it looks like they are, alright, because my legend doesn't say anything, and really my legend should say the different species names. And my IV, which should be on the X-axis, should be these different distances, and it is not. They look like they're on the Y-axis. So my guess is I need to switch rows and columns, which is interesting because it kind of worked, but kind of didn't work. Blah. Alright, so I switched rows and columns, which got me a little closer. Oops. Switch rows and columns. I'm going to see if I can get rid of this and get rid of this. Nope, I want that back. So you just kind of have to play around with it a little bit, which sucks. But it is what it is. And I can look at the series and say, should plot distances from the stream be one of the DVs? No. It shouldn't be, because that's actually my IV. So I'm going to say, remove that. Alright, and that makes this legend work out better, because now the legend only has the actual species names. But it looks like Sheets is really confused about what my actual IV is. And it says add an X-axis. So I can click right here and say, I'll teach you what it should be. It should be this thing, this row. So what I did was I say, I'll teach you. I'll show you what I did again. I clicked right here. I'll remove it really quick, X-axis. I clicked right here and I say, I'll teach you. And I highlighted this whole first row that is the X-axis. I did plot distance through 100 meters. Say that's what goes there. And that worked really well. Fancy that. Alright, now we're going to customize because unfortunately, even though we wish Google Sheets would automatically know what my axes label should be, it doesn't. So we decide no chart title. We add that separately through Google Docs. And we're going to add a horizontal title axis. It kind of says something. This is really better as my figure title. But on that axis right here, 0 through 100, what should really go there? Well, what should really go there probably is just the fact that we are at distances 0 to 100 meters from a stream along a belt transect. Being as specific as possible makes it a lot stronger. For the vertical axis, we could type out that we are doing percentage cover, and it's an average for n equals 5 trials, because that's how many quadrats we did, using 10 by 10 meter plots. Alright, in my title, I could be even more specific about the fact that it was quadrats. Last but not least, within Customize, we want to go to Series. And we can't really add trend lines. It's not a scatter plot. We could add data labels, but that's really overwhelming. We want to add error bars. Now, what's reasonable for error bars? Well, this default 10% isn't making much sense. We could bring it down to 5%, which is related to having about approximately a 95% confidence. But I would suggest going back and looking at the standard deviations and getting an approximate average. It looks like approximately standard deviations here seem to be about 5 or so, alright, which is kind of high, alright. We could see it changes a lot, alright, so let's kind of keep it at 5%. I think that was one of the stronger ones to use. Now the last thing we could see is you could change the chart type instead of being this way to being a stack chart. but that will change how you can read the error bars, and it also made it really mad at me and lost a lot of my chart axes label.